Good day, everyone. It's Thursday, 9 May 2024, and we have this laptop. This is an HP ProBook, and let me see the model. It's a HP ProBook 4530S. That's the model of this laptop. The laptop came in for no power. This is some kind of job from other computer repair shop. The owner of this laptop sent his laptop to one of the computer repair shop. They couldn't fix the laptop. He sent it to another repair shop, and this is the third repair shop, because the owner still have a belief that this laptop can come back to life. So obvious, there's no battery, no screws here. The hard drive is missing. We do have the RAM, the motherboard inside. All right. Here. So what I'll do, I'll plug the charger. I'll plug the power supply. You can see here the power supply is taking 168, 167, 168 milliamps. And here we do have the power on button here. Okay, maybe it's not connected. Let's see. Yeah, it is not connected here. But based on the current, I don't think even if we connect the switch here, this laptop is going to come on. I don't think so. So the switch is connected, pressing the power. So the laptop is dead. Yeah, that's the keyboard. So what can be fault here? I think I want to make a video of a laptop that was a Lenovo G50 series a few weeks ago. I made a video. The laptop was taking 169, was taking around 200 milliamps, and that was a dead E.T.C chip. So trust me, that kind of standby current is not good for a non-working laptop. Either we have I know the main 19 volts power rail in most cases is okay, but we have the problem. We might have problem with the 3.3 volts power supply. The 3.3 volts for the LDO, which is always on all the time, even if the laptop is off. So what I would do, okay, let's see what kind of current do we have on this power supply. 1.9. Let's raise this current. 3.2 amps. But that won't change anything. That won't change anything. Pressing the power, we still have the same current, 169 milliamps. Okay. Do you have screws here? We don't have screws, so I'm sure we must be able to take out the top cover. Yeah, that's the motherboard. So what is most likely to fail here? Yeah, still taking same current. So let's come with the multimeter without wasting time. With the have the charging port here, and it's coming on the other side of the motherboard. But here we have the power supply, we have ceramic capacitors, and the 19.34. Okay. And here, this looks like another power supply close to the processor. Probably it's the vehicle processor power supply. And we have 19.34. Here we have another power supply, 19.34. So now you see, the 19 volts power line is okay. Let's go to the 3.3. How do we check 3.3 volts power supply? Let's check on the switch connector here. Pin number 1. We do have 3.3. We have 3.3. Second pin, 3.3. But on HP it's very easy. We must have light here. On the charging port, there's no light. So we have a 3.3. So we have 19, we have 3.3. So probably we have a dead. That's bad. Don't tell me we have a dead EC chip like last time, because I don't have this EC chip. Yeah. And this chip is getting hot. You remember that chip for the last time? We have a chip here, so let's take out the motherboard. I think I know the story here. I think I know the story. The EC chip is gone. 99.9%. The EC chip is gone. So that's the microcontroller. SMSC startup chip. Let's go on diode mode. The last pin of the BIOS chip. We have a BIOS chip here. We have the controller. Last pin of the BIOS chip is like 00. So let me come with 3.3 volts, because the last pin of the BIOS chip is the VCC pin. That the supply pin should not be grounded. Should not be grounded. So I'll come with around 3 volts, 3.17 volts, 2 amps. I really want to see what is taking that current. And if I come with the 3.23 on pin number 8, is taking 2. Can you see that current? And the EC chip is not getting even warm. So what is the fault? Is it that chip which is getting hot? Okay, let's go on microscope and check few things together. Let's see now. Let's see that the motherboard, and here I checked the 19 volts power line was okay, and there was a problem with this BIOS chip. So I'll stick the brake probe on the ground, and this is ground. Because we have a dot here on the BIOS chip, pin number 1, 2, 3, 4. Pin number 4 is ground. 5, 6, 7, 8. And pin number 8 was beeping to ground. Now it's no longer beeping to ground. So what I want to do, we'll stick one probe on pin number 8. Maybe that was voltage. And we'll try to locate the 3.3 volts power supply. And it's beeping here. Exactly here. So this coil is for the 3.3 volts power supply. So let's see what is on the other side. On the other side, we have that chip which is getting what? This one. We have this regulator. This is a linear regulator on a switching power supply. And what this chip is doing, let me see which chip is this one. 51123. 51123. Let's see what this chip is doing exactly. Let's see what this chip is doing. Okay, we do have the schematics for this chip here. That's TPS 51123. So what this chip is doing is supplying 3.3 and 5 volts. If we check here on the chip, if we check here, let's make this bigger. If we check here on the chip, we do have this 3.3 volts. So this chip, what this chip is doing is outputting this 3.3 volts and this 5 volts. So it has got this one, this output and this output. And not only that, because that's where many people get lost. This chip is outputting 4 voltages. If we check here, we do have pin number 1, 2, 3, 4. Pin number 8. This pin, which has this ceramic capacitor, 10 microfarads. From this pin number 8, that the VREG3, the EC chip, our EC chip or a startup chip or a microcontroller is getting power. So if you see this chip getting what, check here. Either the EC chip is gone, or this chip on its own is gone. So that is the third output. And the fourth output, pin number 13, 14, 15, pin number 16, that's the V-in, which is inputting 18 to 19 volts, and pin number 17 here with the 33 microfarads capacitor, that's the fourth output. 5 volts for the USB hard drive and the likes. So what we want to check I'll check this output for short. I'll check this output. I'll check this. I'll check all these 4 outputs for short. So let's see why this chip is getting hot. So we have a mark here. Can I bring this closer? Yeah, like this. Now it's better. So we have this chip, pin number 1 here with the mark. We have 6, 7, 8. On pin number 8, yeah, that's pin number 8. Pin number 8, something must be wrong here. On pin number 8, here, check this capacitor. What do you think about this capacitor? Why is shorted? Why that capacitor is reading a short? So let's lower the voltage. We want to see. I'll come with the 3 volts because we don't want to damage anything in case if the chip is too good. We don't want to damage anything. So this side is ground and this is plus, and it's taking 3.33 milliamps. I want to check my E.C chip because either that current is being drawn by the E.C chip or that linear regulator. No, the E.C chip is not getting hot. Let's use alcohol. Check the chip. So actually in this case is the chip itself. So this chip is dead. This chip is dead. TPS 5113. Let me just check other things on the other side of the board. Let's check other outputs for this regulator because it's outputting 4 volts. It's outputting 4. It has our 4 outputs. So I'm checking here. This is ground, this is plus, and it's good. And here we have another output here. So basically the chip is fault. Let's not waste time. Hopefully I have this chip. Hopefully I have this chip. because probably without this chip you can't do anything. So let me look for this chip and we'll try to replace it. So let's take down this chip quickly. I found something. Let's take down this chip without wasting time. The chip is out. Oh, what you need to do is to clean the motherboard. All the pins looks fine. Before I came with the chip, let's check that capacitor for short again. And the capacitor is not short anymore. So basically this chip is faulty. The chip is faulty. What do I found is this one. That's the chip. 51123. So let's replace that chip. Let's replace the chip. And that's all. Cooling the chip. Let's cool this chip. Let's cool this chip and we'll see. While the chip is cooling, let's check for short on that capacitor. Not shorted. We now have no short. So we must have a working motherboard. If that is only the problem with this board. What I want to check again on the BIOS chip. I think that was voltage. When I tried to check pin number 8 to ground and there was a beep, I think that was voltage. Yeah, it's not shorted anymore. So let me wait for the board to cool down and then we test together. Yeah, now I think the board is now cool. So it's the time to test the motherboard to see if we now have a working laptop or not. But what I want to do, I want to plug in the power supply. Let's plug in the power supply. I seen light. Check here. You see that light coming on and goes off. And check on the power supply. It's now taking 18 milliamps. That's the normal standby current that I know. So we might be lucky to have a working motherboard here. But I want to check few things on this chip. On this capacitor we have 19, that's the V in. And on that capacitor which was showing a short, we do have 5 volts. So that is the VREC 5. Okay. And this one is the VREC 3, 3.39. So the VREC 5 is present. VREC 3 is present. Let's check those coils. Here we have 3.39. On the other coil, we have 5 volts. So now we have a working power supply. And the chip is now cold. So let's test. Let's test to see if this laptop is now working or not. What do we need here? We need the connector for the screen. And the fan. Where is the fan for this one? The fan is some kind of stuck here. How can I check out this fan? Let's try to take out the fan. So now you understand, even if you fail to fix this laptop, but you have to know how to bring the 3.3 volts power supply always on or again. In our case, the chip was getting hot, but it doesn't mean that the chip is faulty. Sometimes the chip is getting hot because we have a dirty E.T.C chip. So you have to understand how things works on laptop motherboards. The chip getting hot because of 2 reasons. Either we have a dead E.T.C chip or the chip itself is gone. Those are the 2 reasons why in most cases you have this chip getting hot. If you check with the multimeter, nothing shorted, but the chip is still getting hot. You replace the chip with another chip and it's still getting hot. What is the next step? The next step is to check the VREC 3. That's the next step. You have to check the VREC 3 because from the VREC 3, the startup chip is getting power. So in most cases, you'll be having a dead microcontroller. I need just a few screws to hold the motherboard. So that's the story about the 3.3, because many people They get confused there. You check the 19 volts. The 19 volts is on. The 3.3 is off. And the chip is still getting hot. The next thing you say the chip is faulty. Yeah, maybe it can be faulty, but it's not always the case. It's not always the case. Let's plug the power supply. The port didn't insert it properly. Like that. And it's taking 18 milliamps. Now is that moment to test, or I can use a tweezer shorting pins to ground. Pin number 1, pin number 2, pin number 3. Check the current is now taking 1 amp, and you can see the HP log, and the laptop is working. Mouse not detected. It's working. Boot device not found because there's no hard drive there. So this is how you can diagnose a dead laptop motherboard. If you have 19 volts and the 3.3 is missing, or you have 3.3 volts, you know, it is the last step to replace the microcontroller. I always tell on my videos that don't rush up to replace the microcontroller. Maybe the microcontroller is good and we have other faults. Like in our case, we checked the 19 volts was present. The 3.3 was there on the switch before, if you do remember, and the chip was getting hot. You have to check why the chip is getting hot. You check 4 voltages. In our case, there was a dead TPS 51125 or 51123. And VREC 5 was shorted to ground. That's why the chip was getting hot. Because we have the many 3.3 volts, we have the 5 volts, and the chip, what the chip is also doing is outputting 3.3 LDO, which is a very low output power supply, around 100 milliamps. And yeah, so basically we managed to bring back the motherboard to life, and I'll stop this video now. What can I say? Tomorrow is Friday and we are going for the weekend. Just have a nice cool weekend. Probably I will do one more video before we go to weekend. And please like, subscribe to the channel, and also share our videos to your beloved friends and relatives, and see you on the next one. Bye.